that. All right, here we go. Yep. Kendall and Paul, all yours.
All right, thanks so much. Well, again, welcome everybody, and thank you for the introductions already. We are here to present Systems Engineering in Transit, Constraints, Compromises, and Cross Fingers. So I'm gonna just jump through the agenda really quickly here. You probably want to know a little bit more about us, I suppose, and who we represent. We're going to do an overview of systems engineering in the transit industry from our perspective here in the US. We're going to give a little review of some of the constraints that we bump up against when trying to implement systems engineering approaches and projects. We're going to go over some of the ways that things can go sideways when there's not a robust systems engineering approach applied to a project. Discuss some of the compromises that we make or that we try to make when implementing a project, and give some examples of how a little bit of systems engineering can go a long way. So I think we just had our introductions briefly. So again, I'm Paul Padegimas, a systems engineering manager with UNICO Engineering. And this is...
I'm Kendall Dobson, a systems engineer with UNICO Engineering.
And so UNICO Engineering, we are a small construction management, land survey, and for our purposes, systems engineering firm. Our system engineering team focuses on rail transit projects. We're working only in California right now, but looking to expand, of course. We are DBE, MBE, and SBE certified. We have offices in Folsom, California, where our headquarters is, here in Oakland, and also down in San Diego. We recently opened an office. Our ongoing systems engineering team work includes BART's CBTC project, which is why we are in the BART offices right now. The Barton Capital Corridor Link 21 project, building a new Trans-Bay crossing between San Francisco and the East Bay. California High-Speed Rail Construction Package 4, and recently started up on LA Metro's Sepulveda Transit Corridor project, and hopefully many more to come. So let's just kind of give a brief overview of our experience of systems engineering in the transit industry. So basically it's just DMV, right? No big deal. So just to kind of step through the life cycle of these programs and get to some of these constraints that we face, we have these metropolitan planning organizations that in most major metro areas throughout the US are identifying projects, running them by different stakeholders, whether it be local municipalities, counties, the voters, giving them an opportunity to provide feedback into their regional transportation plans, which then turn into things that get funded by voter measures, which are, basically you get to decide. So it kind of is all your fault too, right? Where you go out and the citizens vote on a measure, it gets funded, and then we have a project that is defined, we have a defined budget, and we have a defined schedule. And we know in real life that this doesn't always hold true. There's always some give and take, but when it comes to accountability to the project, at the end of the day, what the public is going to view as, with the media, what everybody is criticizing and causing this high pressure environment to deliver these projects, they're going to look at the measure that was passed, what was the project, what was the schedule, what was the budget. And again, so these projects are highly visible. We're really talking about programs, projects that have budgets beginning with B's, right? We're not really looking at smaller projects. A lot of the time, smaller projects, first of all, can get away without a robust systems engineering approach. The relocation of a sewage waste pipe is a complicated project in and of itself, but maybe doesn't benefit as much from a full suite of systems engineering approaches. And also, they can't afford it, really. It can be expensive to implement a systems engineering approach. However, it does prove to be worth it where it's implemented robustly. Then because they're highly visible, big projects where the public is watching, the media is watching all the time, it's high pressure. And I think that it's just human nature at that point to go to service proven. And in the transit industry, from what I can tell, that seems to be everybody's favorite term. But usually it's applied to service proven equipment. Like we have a radio that's been service proven. It's been used in New York and San Francisco and what have you, and we've seen it be reliable. But we're also talking about processes. So processes that are service proven are the ones that a project manager comes in and says, I've been doing this for 30 years and I've used this process, I've used this approach, and every time I've come in and successfully executed the project. And sure, maybe I've had some hiccups along the way, but I can fix those and I can understand how to narrowly adjust based on the problems that I've experienced. And that's all well and good, but it does kind of preclude a lot of people from adapting new approaches. And because systems engineering, I think, in the transit industry in the US is a bit new, it doesn't get as much exposure because of this service proven mentality. So going forward, we have an agency, we got this measure is approved and it's funded, and a consultant comes on, helps write an RFP with the agency, and they have a systems engineering section in that RFP that is missing sometimes. And almost all projects have a bit of V&V involved, but outside of that, sometimes it's really not even present. We might see it used in the context of engineering technical systems. So somebody saying, an RFP saying that systems engineering involves the engineering of a communication system, which is, we all know that's not what we do, but it is confused a lot. And I think the terminology kind of doesn't help. Got the throwing a bone to the systems engineering experts, we'll say, or to funding requirements. For example, FTA, ITS projects, they have, if FTA is providing funding for those projects, they're required to implement a systems engineering approach. Also, maybe a contract because some system engineer got in, oh, you shall specify ISO 1548 or something like that. It might be in the contract, but oftentimes in my personal experience, I've seen it enforced in a more lax basis.
Have on your desktop. Kind of.
Yeah, so I got it here for reference, and that's it. And then we have the projects like I can think of VTA, their new systems contract for building a tunnel between Berryessa Station and downtown San Jose. And also we have California High Speed Rail Tracking Systems 1 and their CP contracts. Also, they've been really forward in saying we want a real systems engineering approach. But oftentimes it's not specified what the specific standards that will apply to that are, or how they'll be executed. It's left up to the contractor. So I'm going to pass it over to Kendall here.
Thank you. So given everything we've discussed so far, it's easy to deduce that there are constraints to applying systems engineering in this field. And I can imagine that many of you have probably experienced some of these yourselves. A lot of these limitations stem from a bit of a lack of interest and therefore budget devoted to systems engineering on these projects. As Paul has alluded to, systems engineering here in the US anyways in this industry is kind of regarded as the token aspect of the project, if you will. Whether it be due to funding requirements or management demands, these projects tend to devote as little budget as possible to it and look for creative, if you will, ways of performing systems engineering. So one of the first big obstacles we face, as mentioned, is the smaller budget relative to project size. So meaning we have much smaller teams and resources are scarce. And the result of that, and you'll notice this theme here that maybe resonates with some of you, is that sometimes we have to just work with what we've got and make compromises around these things. In this industry here in the US, systems engineering tends to be implemented relatively late in the project lifecycle. So processes and breakdown structures have usually already been defined without our input. So again, we have to work with what's already been set up, even if it's not the most optimal, and try and optimize as we go along. Also along these lines, since they've already done the processes and breakdown structures, they've usually already developed their base set of requirements without a well-defined breakdown structure. And so they tend to be a little deficient in having well-developed requirements, and sometimes there can be a complete lack of derived requirements. And so we really have to, make the best use of what we're given with those and focus on what can be done with what's already existing there. So another thing we face in this industry, which Paul kind of touched on, is that we're kind of the new guys. We like to call it the new guys problem. Since transit is an aging industry, it's been really well established already. We're relatively new on the scene here, and Paul also discussed service proven. And with this concept, we commonly observe that these methods or products haven't necessarily always kept up with the swift technological evolution that we've undergone in the last 5, 10, or even 40 years.
I've literally had to write a white paper defending the use of a modern Euronorm standard against a mill standard from the 1980s.
Yes. This is not the best thing. And what could be better, of course, to provide some adaptation to these tech advancements and implementing systems engineering. Sadly, though, not everyone sees it that way. And so we do still face a great deal of resistance to changing these practices and products, particularly because while they might not always be optimal, they do tend to be the automatic response to meeting a tight deadline within budget. And so more often than not, we do need to just work within the confines of service proven. The other half of the new guys problem tends to come down to working with individuals. I think you mentioned earlier, Paul, but we all know how difficult it can be to convince someone with years of experience to change the way they do something. I mean, I fall prey to this myself with my bad computer habits, like leaving a million windows open and then wondering why my computer is running slow. And
especially when you have somebody that's experienced success, but we're really envisioning something that could just improve, not just maintain the same level of success, but we want to improve.
Exactly. And of course, also, unlike me with computers, they're experts in their field. And as you said, they have been successful. So it doesn't really give a lot of incentive to change up the ways they're doing things. And that mentality does tend to create a lot of resistance to us systems engineers, coming on in, causing a big kerfuffle and, trying to tell people how to do their jobs. And so in order to avoid this, we need to first and most importantly manage our expectations. And second, try and tread lightly. Like, we want to be delicate in the way that we approach the situation when we're trying to talk to someone with years of experience and success into changing their methods. And definitely careful to validate the method they've been using before we go in and put in our 2 cents. And then when we do that, we also want to be very mindful that in, suggesting whatever changes we are, that we're not insinuating that their methods aren't sufficient or bad in some way, even if we do actually feel that that's the case. So definitely a tightrope, and phrasing is everything, which is, perfect, because as engineers, we're all great with words. And lastly, comes kind of the commercial off the shelf or COTS challenge. As the slide says, it's not like COTS in the aerospace and defense industries. In aerospace, as some of you might know, you're working with much tighter specs. Rad hard is a great example. Everything has to be rated to not only go into space and survive in different conditions outside our atmosphere, but also last a long time. Like you brought up Hubble earlier, and so there's really high standardization for COTS in aerospace, and they're even used at all because NASA doesn't really like COTS very much. And conversely, in transit, we use them frequently and we love them. Exactly. And they've been tested and tried, so we trust them. We see them as plug and play products, and it's part of the nature of them that there's a lack of adaptability, which can obviously be an issue, but actually that's really part of the appeal of them for us, because exactly, we save money, we save time, and we can really just take it and then run with it, right? But of course, it's not exactly true, because every rail operator has its own unique hardware, software, operating environment, and so on. And so the configuration of the COTS equipment for an individual project is actually a really big task, one perfect for systems engineers, of course. Really putting effort into that task could end up saving a lot of money down the line when these things end up being not as compatible with our needs as maybe we thought they were. But it's usually underestimated by the rail operator, and consequently, they tend to be on the underprepared side in managing the configuration of the equipment.
On that note, sometimes even underestimated by the contractor installing it.
This is very true until you get there and you realize it doesn't fit. And another challenge we face with just using commercial off-the-shelf products in general is, of course, there are limitations with proprietary information. So we may not be able to actually see the whole system and perform V&V on the whole thing. And so obviously this is a pretty big constraint on what we can do as systems engineers. And it ends up requiring a lot of flexibility on our part and creativity in, doing our V&V, not to be confused with the creativity that's used in defining systems engineering and contracts. And then lastly, just one of the other big differences between our COTS in this industry versus like aerospace and defense is that, of course, again, money, right? We tend to make our choices based on the lowest bid rather than the quality of the product. Like your voter wants to see that you're spending their tax, dollars well, and maybe not like what seems like overspending to them, and, don't really think about the intricacies that go into that. So we have to maintain a good image to the public, which means that sometimes we have to, not focus on quality quite as much.
Save money where you can.
Exactly, but we keep on trudging.
So, oops, I'm sorry, I clicked out of this, pardon me. There we go. So, okay, given these constraints and the genesis of these projects and how systems engineering is not always exactly specified in the contracts, you can never see that we have some little misalignments coming our way. A couple that have been pretty widely publicized, one very recently and one not so much. Honolulu currently is dealing with this problem where they have a new or not yet open rail line where the vehicle's wheels are too narrow and the tracks are too wide. So you'd think maybe that could have been addressed through a robust implementation of systems engineering, but apparently not. So that they're faced with a choice to spend $2 million to replace all the wheels on the trains, but that would make the trains overweight, which would result in a maintenance nightmare, which nobody wants. Their other option is going to result in a longer lead time, but they could replace the track parts and spend $5 million. But if their contractor is found not at fault, which I'm sure they're going to have their best legal team out there, so you never know, Honolulu is going to pay their contractor $130K a day for that year that they're waiting for the track parts, which is something like $46 million, which I'm sure Honolulu is not thrilled about. So you also have this bigger problem, which I imagine most of you have heard of, which is TGV, when, again, there's a theme here, platforms too narrow and trains too wide. So they bought 1,860 trains for a nice chunk of change at $20 billion, and they didn't fit at 1,300 of their station platforms around the country. So they had to spend approximately, and I extrapolated this out from the first set of repairs, but about $300 million to widen those platforms. So what we're trying to do here is prevent costly mistakes. And I find that in these types of projects, the relative measure of success is, we're within 50% of our original projected budget, but these kind of problems blow that out of the water. So what we're trying to do is make sure that at the end of the day, we're delivering the right product. And you wouldn't think with these kind of issues that we'd have to sell too hard, but we still do. So when we have all these constraints, sometimes we have to make compromises.
Yes, we do a lot of making lemonade here as systems engineers in transit in the US, which requires us to be very thoughtful about how we manage our time and effort and, again, expectations. As wrong as it may sound, it is very important for us to understand the absolute needs versus the handbook level depth of processes. to keep systems engineering viable on these US transit projects, we do need to ensure that we're fitting within the schedule rather than trying to stretch the schedule to accommodate our practices, because it's just not going to happen. I mean, we're going to get out of there. So a good starting point for this might be something like laying out our ideal breakdown structure of systems engineering activities and then doing some triage on it. So eliminating steps that are definitely best practices, but might not be essential to meeting the stakeholder needs. And a good example of this might be doing something like implementing a 10% due diligence policy. So rather than always doing a full check on anything that comes across our desk, we might start with a 10% check. If it turns up anything, then we can expand our check. And then if we keep popping up with issues, then we have our justification to spend our time doing a full 100% check of that. But if the 10% check comes back clear, then we move on, keep managing our time well. And this is the kind of strategy that can really help us to fit within the tight schedule restraints that come with these kind of projects. And we can also compromise by making accommodations, such as using tools other than, like the RM tool on the projects that our subject matter experts or other people we're working with are more comfortable. It's not, of course, best practices to work outside of the RM tool, but sometimes we have to do these things to get what we need from people and have them be willing to work with us. So just using the basics, importing, exporting from Excel and Word to accept information from them and give it to them, and then taking on that extra work of aligning things, configuring, making sure that it's going to get back in the database properly. So we have to do some things like that. We can also simplify, taking, again, a little bit of extra time to modify a view for a specific person of the attributes and whatever are going to come out of that RM tool that's only needed for their use, rather than maybe the full thing that we could just, immediately export out. And then other things, just displaying linkage explicitly rather than just having the links there, which obviously if you're going to be using Excel is absolutely necessary. But even if you do get people to work within the RM tool, you may be able to make it a little bit more friendly for them if they're not as comfortable with it, by not having to follow all the links and being able to already kind of see where they're going. And, of course, changing the way we phrase things again, maybe skipping on our lovely INCOSE jargon and going to something, that terms that people are just more familiar with, and even trying to use their jargon instead. And just really anything that makes it a little easier, even if it's a little bit more work on our parts, but that helps us to get them to be willing to work with us more. And just the last kind of thing that we thought of is just in a bigger picture sense, just gradually increasing our implementation of systems engineering on a project rather than jumping right in the deep end. We can use early design phases as an opportunity to catch these issues before they're carried through, and then use those findings to be those systems engineering salesmen and do our pitch and show them the value that we can offer and the money and time that we actually can save if they invest a little bit in us. And then this can be a great way of ensuring that by the time a project gets to later design phases and actual construction, that we're getting a little more leeway to apply systems engineering more robustly and with less resistance. And again, this is a balancing act, because obviously we do have to make sure that we do get ramped up to that maximum implementation before it's too late, despite resistance. But hopefully we can keep it gradual for as long as we can in order to kind of combat that a little bit. And I think, sorry. Go. So it's not all bad, right? There are definitely a lot of benefits. Again, we're always making the best of things, making lemonade, and it's not ideal always, but applying any level of systems engineering to a project is better than not applying any at all. And the more that we can work these practices into projects in the industry, the more we can hopefully, improve and slowly increase the frequency and popularity of systems engineering in this field, in the US particularly, and hopefully expand to other fields as well. Everybody could use some systems engineering. So to kind of end here, we have an example of a positive systems engineering result. As Paul mentioned earlier, the California high-speed rail project actually has done a very good job of implementing systems engineering and has successfully prevented some issues from coming to fruition, including our example of an elevation mismatch between construction package 2.3 and construction package 4, us. The interface between the two packages was introduced earlier in design, and both contractors, attached their drawings. It was really obvious to see that they were planning on ending their track at different elevations. And so at that point, it was pretty easy to fix. CP23 took on that job of redesigning and moving their alignment up by a meter to match up with the construction package 4 elevation, and all was well. And of course, like, this problem would have been identified eventually, but especially given that we're talking about two completely different contractors here, like, it's not completely out of, the realm of possibility that it actually would have gotten all the way to construction and they wouldn't have realized until the end that these things don't meet up at the right elevation.
I, for one, am not really for high-speed trains that act as roller coasters.
No, we don't like that. So, and it definitely would have been if that had happened, because the minimum solution would have been to reconstruct at least 100 meters to make up 1 meter and then have a huge bump in it despite that. And that would have, of course, been a maintenance nightmare, which Paul here doesn't, that makes him cranky. We don't like that. And also, of course, it would have been very costly, which, our client doesn't like and the taxpayers don't like either. So catching it early made it easy to pick up and rectify during design. So yay for systems engineering. And we can end there on a positive note.
So I hope you all took notes, because we're here for any questions you might have. Anybody?
Let's see. Thank you, Paul, and thank you, Kendall. I thought that was well done. A good kind of ad lib and a very friendly kind of environment. I hope that most people got that. And it does give us a state of affairs in the Bay Area. I was quite shocked, actually. I'm thinking rail here in the UK 10 years ago. Now, things are a little different, but you're back in the Wild West, my friends. Anybody have any questions out there?
Yeah, I just, well, not necessarily a question, but just a comment. I thought the one bullet that really grabbed my attention was the fitting the schedule to SE versus fitting SE to the schedule. It kind of has been a drumbeat that we've been seeing a lot of, where SE gets dovetailed into some same as accept schedule that was done, for however many other projects, depending on who the consulting team is that's doing the scheduling part of it. You end up with sort of their out of the box, or at least last used schedule that gets modified. And then, likely there isn't any SE dovetailed into that. I'm almost sure of it, even to the point of sort of review and approval of requirements, or quite frankly, even review and approval of some of the design deliverables isn't often adequately covered in the schedule, other than maybe for one iteration, as a token. So that's something that I think, I don't know, are you guys seeing that in the UK, Mike, that kind of a trend where, the scheduling is sort of taking account of some of the SE front end processes?
I think by now, there are some places that probably do just on the PM side. It's very maybe light on the systems engineering, but most in this business have really latched on where systems engineering and project management and asset management need to coexist. and therefore they need to have processes that tie that together. And they're very much into that because there've been too many hiccups, too many things that have gone wrong with big money involved. So it's still there where you have this, but I think it's a little more, you do see it more integrated, and it's only as smart as the client. If the client doesn't know or care about systems engineering, then they're not going to put it in the contract because they don't know how to check it, unless they hire people like yourselves, to do that. So that's my opinion. But Carl or anybody else?
Well, sorry, I just chime in, Simon Hughes from UNICO. I know, Oliver, you're on the call, and obviously you were instrumental in getting SE into the high-speed rail project. How did you do it?
Well, sometimes you ask forgiveness.
That's it.
Hey, but before I answer, so hi Paul, hi Kendall, good
Hi,
job,
Oliver.
Simon. Happy that you're pushing, beating the drum. And now, Simon, to your question is, in 2014, I gave a presentation of how to get SE off the ground, and one of the things is just don't ask approval, ask forgiveness. Yeah, just do it, and you have to show some value. Yeah, because what we just talked about, the schedule, is obviously every time you want to do something, it takes effort and it also takes time, right? And that immediately says, oh, we can take more time. So you have to, but the most effective way I found was taking some issue they have been tinkering with for some time and couldn't find a solution with, and basically just solve it for them, right? Using systems engineering, whether it's finding flaws in design or finding whatever, right? Your requirements-based review. And I had several of those people says, how did you do this, right? And then you come back and well, I just took the criteria and I systematically reviewed. I created a list of interfaces and checked it off, and so you start adding value, right? But yeah, it doesn't have to be the whole thing. You just start very small, and over time you build credibility, and then it grows over time.
I agree. That's exactly kind of what we're thinking too, Oliver. Just that you prove your case in a small piece of the project, and then you say, all right, well, look, I helped avoid some headaches, so let's push this forward a little bit more.
Yeah, and so I also used one of my favorite Dilberts back then, right? By saying, Dilbert comes to his boss and saying, hey, I have a solution to spend $10,000 and save $1 million. And the boss says, well, yeah, but we got to spend the 10,000 and somebody else is going to save $1 million, so it's not feasible. So what you have to do is you have to find basically a fast, let's say, return on investment, so to speak, something that within a couple of weeks or months pays off. Otherwise, it's just what they see as an investment, and they have to spend time and money, and then they just say, yeah, thank you, but no thank you.
Absolutely.
All right, we have two questions, one from Pete Brown and another one from Marcel. I think, Pete, you were first.
Yeah, thanks. Thanks for the presentation. That was really good. Just a quick question on the example you gave from California high-speed rail. I'm curious, when the interface issue between those two contracts was identified, how engaged did California high-speed rail have to get in order to prompt action from one or both of those contractors to change their design to eliminate the problem?
To be completely honest, I'm actually going to refer you to Simon, who's also on this call. He was, we're part of the team that helped identify that issue, but Simon was the one leading the way there. So Simon, if you could chime in on that.
Yeah, of course. Actually, I think it was probably just taking Oliver's point that it was about the time that people were beginning to see the value of the little wins. For the first year and a half, I suppose, on the VMV side, we were tail end Charlies. We were asked by the contractor once a design is done, do your VMV and don't hold us up. And then as you start to see and pick up issues, and you go back to the designer and say, well, you've missed a requirement. Oh, no, we've been doing this 30 years. We couldn't possibly, well, you have. And I think actually the interfaces and probably hit around about that right kind of penny dropping moment. So we'd set them up and Oliver had sort of got a really great structure in place as to providing the interfaces to us in the doors environment, which started to set up the ICDs and capture them. And in actual fact, because it was in such an early stage of the project, both contractors were really at the sort of the 60%, 30% design stage. We didn't really get any resistance at all. I think we just timed that one right. Oliver, you've probably got other examples. I remember sitting in a meeting with you when I was in your team and, trying to convince, and I can't remember which other contract it was, that they needed to look at these interfaces, and randomly picked a drawing, and sure enough, it didn't comply. But I don't remember there being much pushback on the particular elevation, but were there other examples that they have been more reluctant?
Yeah, and Simon, just for the rest of the gang here, Simon actually worked on the authority as the interface manager for a couple of years as well, right?
Yep.
And so we had, and Mike, you would know, I wrote a paper on interface and integration management on high-speed rail. And basically what we did is we used the European technical specifications for interoperability as a basis. And then what we do is we have several procurement contracts. We have civil works, we have tracking systems, train sets. And so, but the infrastructure is built first. We want to make sure that the infrastructure is built properly. And so I can tell you we had interfaces, for example, with certain, not only, with elevations, but also we need to make spatial provisions or certain, let's say, grades the trains can climb, and also for traction power face brakes. And we had tons of those, especially with the face brakes. It was just too steep. Yeah, the trains wouldn't be, because they are not without power between two power segments for a couple of seconds. And so we found many of those issues, but only because we had, let's say, if you want to, for lack of a better word, a checklist of interfaces, and then we trickle them down to every single type of infrastructure, to whether it's trenches, tunnels, earthworks. And then we're saying, hey, for this type of civil infrastructure, you need to consider this and this and this. And then very systematically, we just go through and ask the contractors of every submittal to give us proof back, right? The objective evidence that this was adhered to. And then as Kendall adhered to, we just do a very high level check on our side, because it was supposed to be caught in the earlier process. And if we find something, then something is wrong. So, and it's not only interfaces. We also had plenty of, some people even refer to it as shooting fish in a barrel. Sometimes it's very easy because people just design and saying, hey, I'm the expert, and you come back as the new guy and prove them wrong, which is quite embarrassing. But once you have done this a few times, you get, respect and credibility, I guess, right, Simon? That's what you're saying.
Yeah, that's exactly what
they take it serious.
Yeah, definitely. And I think from a pitch point of view, the requirements management element is the easiest to try and sell to people who aren't sure.
Yeah, you just got to find a few, right? And then saying, well, you say 100%, I say maybe 70. Do you have the other one?
Right. Yeah, and you can look someone that's got 20 years design experience in the eye and say, well, your project manager's got a schedule, right? Well, of course they have. And I imagine your project controls team have got some cost software. Yeah, of course. Well, what's your design team? How do they manage the requirements? You've got, I'm sure there's a thumbed paper copy of a standard in the corner of one office, and I'm sure there's a PDF of something else on, Bill's computer in the corner over there, but Bill only comes in on a Monday, so how are we going to get that? And the environmental team are out getting constraints on, where the tunnel portals can go or hours of working. And you look and say, how are they going to keep all that up to date and manage it and make sure what's applicable applies to what package? And that's about that's been what we've found to be the biggest hook. That one for us seems to be what sort of gains a bit of interest.
Good, thanks.
All right, thank you. And we have Marcel, has been waiting for a long time.
Yes, thank you very much. First, I want to make a comment on what was said about the investment of 10K and earning $1 million. In the Netherlands, we try to find out more about contracts, not a contractor with a client, but together. So if we invest as a client 10K, we also get something back from that 1 million. Maybe that's a solution for you also in the US. And the other observation I had, there were actually two. For instance, in the Netherlands, we don't have a special degree in railway engineering. There's no official education, not on a university, not on another school about railway engineering. So you have to learn on the job from experienced engineers. So what that gives us is we have only a very limited amount of experienced people who are capable of designing railways. That means they have some kind of power. And so what they actually say is, why use system engineering? We've done it for plenty of years. We are the experts. So what are you coming to tell us, new guys? What's your opinion on that? And after that, I have another observation.
Of course. Yeah, I mean, I agree completely. That's exactly it. Like, this guy has been around for a long time. Why do I want to listen to these new systems engineers who are coming in here trying to tell me how to execute my project? And similarly here, we do have railway engineering and systems engineering degrees available at some universities here, but they're very few and far between. We don't have a very prevalent systems engineering practice here in the US as far as you go to school and you get a degree in it. Same thing with railway engineering. So yeah, it's all learned from, I think, on the job experience. And again, nobody wants to listen to what somebody like myself is saying when they've done this for 30 years and they have an approach that works for them.
And the other observation I had was, well, we have what we call a large installed base. We have sleepers of one kind, not several producers are allowed to deliver sleepers, for instance. And the same goes for the track, and the same goes for the overhead lines. So why make specifications for that? That's their opinion. And also the old guys say, well, we've done it for maybe 100 years this way. So don't tell me where the interfaces are. I know them already by heart. You can wake me up in the middle of the night and I know all the interfaces, so never anything goes wrong. So why use system engineering? That's their opinion. And of course, we can prove, like Oliver, that they are wrong. But again, that's the reason why it's so difficult to convince many of the railway engineers to use system engineering, to use the holistic approach. What's your opinion on that?
Let's see, I think in general, I'm in a complete agreement where, yeah, nobody wants to change their approach. They have, I don't, as far as the, hey, build this is all of your scope and a design build contract structure, we need you to build an overhead catenary. There's some merit, I think, to letting a design build contractor go and just do their work at that point. So we need to achieve this, you write a performance-based specification. We need to achieve this basic level of performance, contractor go do it. And then the contractor is just held accountable to it at the end. And they have to have, but to execute that properly, they have to be implementing some type of robust systems engineering approach internally. I don't think you're going to find too many examples of projects being executed and, you know, getting there on time, on budget, and delivering the agreed set of services without having some type of process in the background to make sure that you're designing to requirements, and then when you're building to design. So I think maybe the client, maybe the owner agency in that situation where they hire a contractor to do an overhead catenary, maybe the systems engineering process really isn't embodied by the client at that point, but it must be embodied by the contractor. And I think it's fair to specify in request for proposals that the contractor shall implement a specific system engineering process to ensure that they get their design right, that's subject to audit by the client. I think that's a pretty fair approach. We're not going to interfere, but we might come in and spot check you to make sure that you're actually executing the project to deliver what we agreed to pay for.
Yeah, I agree. Thank you.
Thank you.
And the final observation I made was we try to avoid the word system engineering, and
Yes.
because many of them think, well, that's new, and we try to think of things they already know and are experienced with. So they always had to prove that the design was right and it could be validated, but we do not use the word verification and validation. Just show me the review, the technical review and the process review. And if you use that, then there's nothing wrong. Then they don't get hicked up, they don't get afraid, they don't get mad, and we just get the things done. And we of course use the system engineering jargon, but we don't express them to them. And that really helps us to get forward.
I think that's very true. And to that point, one thing that I didn't discuss like during that, kind of compromise thing, but I think kind of goes along with that is like, in addition to kind of avoiding some of those triggering words, also like it can be kind of a matter of what Simon was talking about with really appealing to that requirements management part and kind of like almost, like stroking the ego a bit and making it kind of about how like, you as an expert, like you're really in your ways because you really care about this and it means a lot to you that it's done your way. So let's actually put in the effort to check all these things, write good requirements and make sure that it is done your way and that you get what you want, and kind of framing it in that, sense as well.
But again, also using language that's familiar to the person that you're talking to. So that subject matter expert, you're right, systems engineering is not a great term to use. If you try to sell that, again, between the confusion about what systems engineering actually means, because plenty of people say, oh, systems engineering means we're engineering systems of technical
writing software,
technical equipment or writing software. Yeah. So I think you do have to stick within their set of terminology that helps frame it in a way that it's not this new thing. It's just a better way to do what you were doing, or is going to help you get done what you already were trying to do.
Yeah, well, I have to comment on that one, if I may. System engineering in the Netherlands sometimes is equivalent to paperwork. Lots and loads of paperwork. So that's why the other reason why we avoid the word system engineering in some industries.
That makes sense.
How's this? Does it? Okay, thanks.
Yeah, no, I think here people who are broadly familiar with systems engineering do think, oh, these guys are just coming to give us lots to do. Like, yeah, I'm going to have to go through and sit and look at this requirement and run through a quality checklist. And it's just going to take time that I don't have because I have other things I need to get done.
Exactly.
I just want to look at the requirement and move on. But so, yeah, I think there is a negative connotation to systems engineering here with a lot of the people who have been established in the design world and just think we're asking them to do more work.
Yeah. And if we approach it with a risk-based approach, well, we say, well, you already made a checklist in the old times, checking whatever you engineered. Well, we use the same checklist again, but this time with other words. And if we approach it that way, then they don't get afraid. They don't hesitate to do it. They just do it, and it helps them.
Absolutely, and I think you can use things too, like some I've seen in many times on projects that I've worked on.
Yeah, just a follow up on
freezing there.
Yeah, freeze.
Yeah.
Oh.
Well, thank you very much for allowing